Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. And I also welcome you to this series of lectures where we are discussing the first chapter in 11th chemistry, which is some basic principles of chemistry. In the last class, I discussed about laws of chemical combinations, right? And I gave you a list of these laws. So, if I want to recapitulate, we discussed the law of conservation of mass, law of definite proportions, and law of multiple proportions. So these three laws were discussed in the last class. In today's class, I will shed some light on the other three laws, right? Along with that, I stopped at a question in the last class. So now let us start at the same question based on law of multiple proportions. Right. So this was the question. Right. So in this question, you can see that you have 6 grams of an element. 1 minute. Let us see. Yeah. You have 6 grams of an element A, right? So let us convert this question into mathematical formula so that solving becomes easier. So A is 6 grams, right? A is 6 grams, and then you have 16 grams of element B, right? So let us label this as experiment 1. So this is your experiment 1. Now this forms a compound X, right? In another experiment, 3 grams of element A. So another experiment, let me label it as experiment 2. 3 grams of A. Three grams of A reacts with 4 grams of B. Right. Now again, this leads to the formation of a compound Y. So what does this data illustrate? Well, you can clearly see that you have 2 elements, right? You have 2 elements forming more than 2 compounds, correct? And whenever you have 2 elements forming more than 2 compounds, it is a clear case of law of multiple proportions, right? But still, let us check whether this data follows that law or not. Now, according to law of multiple proportions, you need first fixed mass of one element, right? Now, let us take that one element as A. Now, to fix this mass, what I suggest to you is divide this experiment 1 data by 2. So, if you divide this experiment 1 data by 2, you will get 3 grams and you will get 8 grams, right? And the lower data is again 3 and 4, right? So this is 3 grams and this is 4 grams, right? So this is your A, this is your B. Now according to law of multiple proportions, ratio of this should be simple whole number. Let us check. So if you do a ratio here, you will get 2. So the ratio of B will be 2:1, which is a simple whole number ratio, right? So yes, this data and these experiments and also the compounds formed follow what? Law of multiple proportions. Now, ending this law, we are going to move on to another law, which many people feel that it is a little complicated. But you don't need to worry. It is my job to make it simple for you, right? So let us first see what this law is. This law was proposed by Richer, right? Now read the statement carefully. When two different elements combine separately with the same weight of a third element, right? See, law of multiple proportions had 2 elements. Now you have 3 elements, right? So, so suppose you have two different elements. So suppose I have element 1 and I have element 2. So two different elements combined with the same weight of a third element. So these elements combined with a third element, okay? The ratio in which they do so, right? The ratio of this E1 is to E2 will be the same or simple multiple ratio in which they combine with each other, right? So what does this law indicate? To understand this, obviously we need to take an example. Without an example, it is not possible. Same or simple multiple ratio in which they combine with each other. So here you have 3 elements. Suppose, let me take this first example, right? 3 elements. So let carbon be the element, right, with which oxygen and hydrogen combines. So you make a triangle like this, right? So now these 2 elements have to combine with carbon, right? So the compound which is given is carbon and oxygen is carbon dioxide, and carbon and hydrogen is CH4, right? And oxygen and hydrogen combine to form H2O, right? So the very first thing you have to do is find the masses of these. So here you can see that this is 12, right? And this is 32, right? One oxygen is 16, 2 is 32. This is 12 and this is 4 grams. Right? Now here you don't have to do anything because see the mass of carbon, fixed mass of carbon is there. So these 2 elements combine with the fixed mass, which fixed mass is what here? This is the fixed mass, which is 12 grams of carbon, right? The ratio in which they combine, the ratio in which they do so means the ratio in which these elements combine with the fixed mass of carbon. That ratio you have to find. So ideally what you have to find, if I want to find O is to H, right, this will be 32 divided by 4, right? It will be 8 is to 1, right? That will be the ratio. Understood? So now this is the first ratio, right? Right. That ratio will be the same or some simple multiple of the ratio in which they combine with each other. So one ratio was you fixed the mass of the third element and took the mass of these 2 elements in these 2 compounds. You took the ratio. This is the first ratio. Second ratio is when these 2 elements combine with each other, then also you have to check same O is to H ratio, right? Now let me check the second ratio. Oxygen is here 16, hydrogen is 2, right? Oxygen is 16, OH, oxygen is 16, hydrogen is 2. Again you will get ratio 8 is to 1. Can you see the ratio is the same, right? So that is what we mean by will be the same. Now not only this, it can also be like this. So this is a example of law of multiple proportions. Done? Right. So let me just take, if I have another example here, carbon, sulfur and oxygen, right? This example I think is not here, but let us take these three elements, right? So you have carbon dioxide here, carbon disulfide is the compound here, SO2, right? So here, if you see the mass, so the fixed mass of the third element is carbon. So carbon here is 12, here also it is 12. Sulfur is what? Sulfur's molar mass is 32. 2 into 32 means 64. So this will be 64, this will be 32. First ratio is, you have to find the ratio of, first ratio is sulfur by oxygen ratio, which will be 64 by 32, right? 2:1, right? This is the first ratio that you have found. Second ratio will be ratio of the weights of the elements in which they combine with each other. So this will be 32, this also will be 32, right? Now see, now the second ratio of sulfur by oxygen is 32 by 32, which is 1:1. Now these ratios are not same. Yes, see, I've written here same or some simple multiple of the ratio. It will be same or it will be multiple of the ratio. What do I mean by that? See, the ratio is this. For it to be equal to this ratio, I can multiply it by. So this is the multiple, right? So these ratios can be equal, or the first ratio can be multiple of the second ratio. Okay. So even this follows law of reciprocal proportions. So that's why I specifically took this example. People tell you the same ratio, but they will never tell you whether it is a multiple or not. Right. Now I want all of you to have a look at this and see this screen for a time, right? Take your time and find how much and how many things follow the law of multiple proportions. Right. See, for law of multiple proportions, you have to have three elements. Three elements, right? So what are the three elements here? One is carbon, oxygen, and you have hydrogen. Right? Three elements, right? Next thing, there should be two compounds in which one element is common. Two compounds in which one element is common, and in these two compounds the other elements should combine with each other to give you the third compound. Correct? Carbon is the fixed one. The ones which are not fixed, they combine with each other to give you water. So this follows the law of multiple proportions, right? Now here let us see which element is common. Okay. Now in these two, sodium is common, correct? And the ones which are not common, they combine with each other to give you the third compound. So here also valid. Let us talk about this one. Now here, be careful. Okay, how many elements do we have? Okay, we have three elements: sulfur, oxygen, and carbon. Now, now what is the problem here? See, sulfur is common in all the three compounds. Now that cannot be possible. Sulfur cannot be common in all three compounds. It should be only common in two compounds, right? Everywhere you see, there is no single element which is common in all the three compounds, right? You will have elements only common in two compounds. If it is coming common, so here it is not applicable. Coming to this one, Okay. In this one, okay, we have nitrogen and nitrogen common, oxygen also common. So oxygen combines to form this. No, hydrogen is not at all there anywhere. So this also does not follow law of multiple proportions. So in this way, you can classify molecules which will follow or which will not follow law of multiple proportions. Now coming to this question. Let us take this question at the end when I finish up all the laws. It is a little longer question. It will take little time. We'll get back to this. Don't worry. I will never leave any questions unsolved. But because I know it is a little longer question, we will take it up in the end. Moving on to the next law, which is law of combining volumes given by Gay-Lussac. So the law is called Gay-Lussac's law, right? Proposed by obviously by Gay-Lussac. When gases react, they do so in simple multiple ratio of volumes. And if the products are formed are also gases, if the products formed are also gases, all the volumes bear a simple whole number ratio provided by the volumes are measured at the same temperature and pressure. What do I mean by that? I mean is that if you have a reactant 1 which is a gas reacting with a reactant 2 which is also a gas, if they give a product 1 which is also a gas, then suppose if this is the stoichiometry, suppose I write here 2, I write here also 2. See, in terms of moles, you know how to interpret this equation, right? It means that 2 moles of this reacts with 1 mole of this to give you 2 moles of this. What this law basically tells you is that if everything is a gas, remember only and only when it is a gas, right? If it is a gas, then I can also say that 2 volumes of R1 reacts with 1 volume of R2 to give you 2 volumes of P1. Volumes means what? ml, liters or anything, right? So this, in the same way the mole law is applicable on equations. Instead of solids or liquids, if you have gases, then gases you can directly interpret in terms of volumes. Now let me pause here a little bit and tell you an error which people will carry out in this interpretation. See, instead of gas, if this was a solid, then this first thing is true. The moles one is true. But this second one is not true. Why? Because now it is a solid. This law is only applicable to gases. So now I cannot say this. But what can I still say? I cannot say how much volume product is formed, but what can I still say? I can still say that 2 volumes of this gas reacts with 1 volume of this, or I can say 2 ml of this reacts with 1 ml of this to give you 2 moles of product, right? So this is your Gay-Lussac's law. Simply volumes are related directly the way moles are. Another example is here. You can see the stoichiometric coefficient coming here, right? Here 1, 1, 2, 2. Okay. This law is also called law of definite proportions by volume. Okay. If you take out the ratio here, what will be the ratio again? In this one, if you take out the ratio 2, 1, 2, right? That will be the ratio. And remember, this reaction should be carried out at constant temperature and pressure. This is the Gay-Lussac's law of combining volumes, right? Right. Now, using this law, Have a look at this question and see whether you can solve this question or not. See, first write down the equation which is given to you. The equation is N2 gas. Yeah, these things in the bracket are important. H2 gas giving you 2 NH3 gas. So everything is a gas, right? Okay. So now they have fixed the temperature and pressure at 298 Kelvin and 1 bar, correct? Now 3 liters, they have given you the volume, 3 liters of nitrogen reacts with X liters. So X liters of hydrogen to form 6 liters of ammonia, correct? Now how to interpret this? See, how can you interpret this? See, if directly from the equation I can tell that 1 liter of nitrogen can react with 3 liters of hydrogen to give you 2 liters of ammonia. This I can directly say, correct? So if 2 liters of ammonia is given by, we are going to use unitary method. If 2 liters ammonia is given by 3 liters of H2, then tell me 6 liters of ammonia will be given by how much H2? See, for this, I have already told you unitary method. See, you have to determine the liters of H2. So, what you need to find, keep it in the numerator. So, 3 liters will come in the numerator, right? What you do not have to find, ammonia, keep it in the denominator, right? And with what you have to find? 6. So, multiply it by 6, right? So, answer will be 9 liters of H2. Okay. Answer will be 9 liters of H2. You can directly go do it from here also. How? If you multiply this complete by 3, then see, you have to make it 6. It is a ratio. Understand this? This is a ratio. If it is a ratio, you can multiply it by something common. So I can write here 3 liters. This becomes 9 liters and this becomes 6 liters, right? So you still get an answer which is 9 liters. Do it by this method or do it by this. Choice is yours. Wherever you feel comfortable, you can use the methods, right? Moving forward, I think it is understood. Avogadro's law. This law tells you that equal volumes of all gases, see, equal volumes of all gases, right? Of all gases, what I have to say, of all ideal gases, just this is law for ideal gases, equal volumes of all gases. So suppose I have oxygen gas and I have hydrogen gas, right? I have it in a container, filled in a container, fill in a box or something. Or let us be 2 boxes, 2 separate boxes. So equal volume. So means this is suppose 3 liters, this is also 3 liters. Under similar conditions of pressure and temperature, okay, maybe this is at 180 m, 273 Kelvin. This is as 180 m, 273 kelvins, right? Contain So what does it mean? Moles of O2 here will be equals to moles of H. Contain equal number of moles, and if moles are same, you know that how to convert moles into number of particles? Just multiply it by Na. So if you multiply these by Na, so Na NO2 will be equals to Na NH2, right? So this is the moles relation. This is the number of particles relation, right? So this is this law in form of mathematical statement, right? Equal number of particles, or in my case molecules. So equal volume of ideal gases at the same pressure and temperature contain equal number of moles or equal number of particles, or I can say here molecules, right? Equal number of molecules. So this is the way you interpret this law. Okay, atoms may be different, you will understand this. Now, if you have understood this, let me tell you the basics or basis for this law, how this law came about, right? See, to understand how this law came about, you need to know about this equation, PV equals to nRT, right? This is the ideal gas law, whereas the P is the pressure, V is the volume, T is the temperature, the R is some gas constant, and N is the number of moles, right? So this is your pressure, this is your volume, this is your moles, this is your gas constant, and this is your obviously temperature, right? And this is called the ideal gas equation. Ideal gas equation. Now, suppose I have two gases, right, with equal volumes, right? So equal volumes, and they told that under similar conditions of pressure and temperature. So pressure and temperature are also same, volume is same. So suppose I take gas 1, right? So pressure is suppose P, volume is V, temperature is T, right? So let us see how can I write the moles. Suppose N1 is equals to PV by RT, right? Understood? For gas 2 also, because now the pressure is the same as the above gas. Remember this, if pressure is around, see R is also, pressure is the same, similar conditions of pressure, volume is also same, temperature is also same, R is a constant which is already same. So this will be also PV equals to RT. So can you not see directly here that this implies that N1 is equals to N2. So that is how this law comes from the ideal gas equation, Avogadro's law, right? Right. So now this is some small exercise to make you understand how much you know about this law. See, I have 4 gases here, right? The first one is hydrogen, second is your carbon dioxide, sulfur dioxide, and methane, which is CH4. So mole, suppose I take equal moles, right? So if equal number of moles are there, then tell me how many molecules it will have. Molecules will be Na into N, here also molecules will be Na into N, here also molecules Na into N, here it will be Na into N. So these many molecules you'll have. But what about atoms? see, one hydrogen molecule has two hydrogen atoms, right? So if these are the number of molecules, you have to multiply this by 2 to get the total number of atoms. So it will be 2 Na. Right. Similarly, in carbon dioxide, one molecule has 3 atoms, 1 carbon and 2 oxygens, correct? So if you have to multiply and get the atoms, this will be 3 Na into N. Similarly, here you have 3 atoms, 3 Na into N. Here you have 5, 4 hydrogens and 1 carbon. So 5 Na into N. Right. So that is what I meant by atoms may be different. Right? I've written here equal number of molecules, moles, but atom may be different, may not be different. So what do I mean by that? See, atoms may be different, may not be different. Right? This is may not be, this is the same, but here it is different. So about atoms, we cannot say anything with certainty, but for molecules, yes, we can. What is atomicity? Atomicity is nothing, number of atoms in a molecule. So atomicity of this is 2, atomicity of this is 3, this is 3, and this is atomicity as 5, right? Atomicity, just write down, it is the number of atoms in a molecule, right? Number of atoms in a molecule. So note this down, register it in your brains, right? And now, if you have understood this very completely and easily, I am going to move forward to the next concept. Okay. Now this comes the exercise. Now before I move on to this exercise, right, let me go back to that question which we left, which I told you is little bit on the longer side. So this is the question. So our laws are over. We talked about law of reciprocal proportions, Gay-Lussac's law of definite ratio of volumes, and also we talked about what? Avogadro's law. Now read this question carefully and let us try and solve this. Carbon dioxide, read it with me, carbon dioxide contains 27.27% of carbon, correct? Carbon disulfide, which is CS2, contains 15.79% of carbon, and sulfur dioxide contains 50% of sulfur. Are these figures in agreement with the law of reciprocal proportions? Please have a look at it, think about it, right? It's not that easy, and I will solve this question for you, right, as we move forward. First, write down what compounds are given to you. You have been given CS2, SO2 and Cu2. First, check whether the law of multiple proportions is law of reciprocal proportions, law of reciprocal proportions is valid here or not. See, if I fix one element, which element should I fix? Let us fix carbon, right? So you have carbon because it is already fixed. So carbon I have fixed. Fixed element. Now the other two elements should form compound. Yes, this is compound between sulfur and oxygen. So, okay, the first test is passed. Yes, it can follow the law. But does it actually follow? Let us check that out. So let us make a triangle again, the triangle of law of reciprocal proportions. Now here you have carbon, then you have sulfur, and here you have oxygen, right? Carbon sulfur forming CS2, carbon oxygen forming CO2, and sulfur oxygen forming SO2. Correct? Now carbon dioxide contains 27.27% of carbon. This is of carbon. What about oxygen? Well, so for carbon dioxide, let total mass of CO2 is 100 grams. If that is the case, then I can say that mass of carbon was 27.27 grams. What about mass of oxygen? 100 minus 27.27. Right? 9, 9, 9, 10, 3, right? 7, 2, and 1 minute, 7. So 72.73 grams will be the mass of oxygen in carbon dioxide. After we have done this, let us move to CS2. Here also let total mass of CS2 be 100 grams. Then mass of carbon will be 15.79 grams. And what about the mass of sulfur? Yes, obviously, you have to minus it from this, right? 9, 9, 9, 10, right? 1, 2, 4, 8. 84.21, sorry, not percentage, now it is grams. Grams. So I've calculated the mass of oxygen and mass of sulfur in carbon dioxide and carbon disulfide. But the problem here is, what is the problem? Why we cannot apply that law? See, mass of carbon is not fixed, it is different. Here also it is different, and here also it is different. So how do we move about working with this problem, right? So how do we move about? So we have to fix mass of something 1, right? So let us now fix the mass of carbon as 1 gram. So we know that if mass of carbon is this, then the mass of oxygen should be this. But if the mass of carbon is 1, then what will be the mass of oxygen? So I can write here that mass of oxygen combining with 1 gram carbon. How will you find this? Again, same. What you have to find? Mass of oxygen, keep that part in the numerator. What you do not have to find? Mass of carbon multiplied by 1. Try and solve this. What you will get? One minute. Let me just check the question once before we move forward, so that our calculations are not gone wrong. Okay. Right. So let me just approximate this to 73 and approximate this to 1 minute. So 27, right? Now if you solve this, right? If you solve this, you'll get an answer around 3 is to 1. Right. Approximately you will get 3. How you will get 3? You can clearly see here. Let me just check it out. Once again, you have 73 by 27. Let us just cut it by 3, that will be better. Right. So 3 9s are 27, 3 2s are 6, 3 4s are 12, 3 3s are 9, 3 8s are 24, right? So it is coming out to be 8 by 3, right? 8 by 3. 8 by 3. Right. So if I divide this, it will be around, okay, let it be 8 by 3 for now. We'll see afterwards. Right. So in this case, the mass of oxygen combining with 1 gram of carbon is 8 by 3. Let us move on to this part now. Mass of sulfur combining with 1 gram of carbon. How much mass of sulfur will combine with 1 gram of carbon? How will you do that? 84.21 divided by 15.79 multiplied by 1. Right? So this one also, if you try and solve, this will come out to be, if I take this as 84 by 16, right? If I take it as 84 by 16, see, these kind of approximations you need to do. If you have these kind of decimals, it's almost impossible to do it, right? The 4 4s are 16, 4 2s are 8, 4 1s are 4. Now, if you approximate it, even if you approximate this, both approximations will come out to be 2.7 in this case, and I think in this case it will come around 5.25, right? Because 4 5s are 20, right? It is fine. So this is your oxygen and this is your sulfur, right? So the next thing is we have to find their ratios, right? We have the oxygen and we have sulfur. Next we have to find their ratios. So let us do that. So sulfur is to oxygen, 5.25 is to 2.7. I told you to, if you do not get a whole number ratio, you have to divide by the smallest number. So divide both sides by 2.7. So here you will get 5.27 divided by 2.7 is to 1, right? and this approximately, if you try and cancel it out, it will come out to be 2, right? See, you're getting around 5.4, right? Around 5.4 value you will get if you multiply it by 2. So let us take advantage of that, right? So this value will be approximately 2, right? So the ratio that you will be getting is around 2:1, right? 2:1. This is the ratio of what? Let me just erase this also now. Right. So we had carbon, sulfur, and we had oxygen, right? And this formed carbon disulfide, this formed carbon dioxide, and you have sulfur and oxygen here also, right? So now let me take sulfur dioxide, which we did not take till now. It says that 50% of sulfur it has. If it has 50% sulfur, what does I mean? If total mass is 100 grams, then mass of sulfur will be 50 grams, and again mass of oxygen will be 50 grams, right? This is the second ratio that you have to calculate. If you do the ratio here of mass of sulfur to mass of oxygen, you will get 1:1. But here, ratio of sulfur is to oxygen is what? 2:1. So does it follow law of reciprocal proportions? Well, yes. I told you it can be the same ratio or it can be a multiple of that ratio, right? It can also be multiple of that ratio. So in now what we have simply is you have a multiple of the ratio. You can see here, right? 1:1 will become equals to 2:1 when you multiply it by 2. So this is your multiple. So yes, it does follow law of reciprocal proportions, right? So digest this question, keep it in your mind, right? Now let us move on to the questions which I have left towards the end. Now in the end we are going to do some very easy questions. You're going to do them in a jiffy, right? Because we have dealt with difficult questions. So those questions will seem easy to you. First question. Which law states that matter can neither be created nor destroyed? Now this is not even a question. It is very easy. We know that law of conservation of mass. Now moving on to the next question. Which law states that if two elements can combine to form more than one compound, two elements combining to form more than one compound, this indicates which law? Law of multiple proportions. The mass ratio of one element that combines with fixed mass of the other element will be in the ratio of small whole numbers. Which law? Law of multiple proportions. Next question. 4.88 grams of KClO3 when heated produces, let us see this equation, let me write KClO3, you are heating it, producing oxygen plus KCl, right? So 4.88 grams of KClO3. Yeah, this is not balanced. So you have to put 3 here, I think. You have to put 2 here. And to balance this out, you have to put 2 here, right? Results in producing 1.92 grams of oxygen and 2.96 grams of KCl. So check whether 1.92 plus 2.96 is the answer coming around 4.88 grams, means mass on this side is equal to mass on this side. So which law it illustrates? Law of conservation of mass. Now carefully read this. See, in these questions, my suggestion to you will be convert the questions, whatever questions is written in a word format, convert it into a mathematical format, convert it into equations. The mass of nitrogen per gram of hydrogen in the compound hydrazine. So hydrazine is this. The mass of nitrogen. So mass of nitrogen per gram of hydrogen. Understand this, when you say per gram of anything, it means this division is exactly 1.5 times the mass of nitrogen in the compound ammonia, right? Mass of nitrogen in the compound ammonia. So tell me, mass of nitrogen, right? Obviously, right? What is this? This is law of multiple proportions. I don't have to go further. There are 2 compounds, 2 elements, right? And the ratio of the masses is given you as, right, this. So this is law of multiple proportions, right? Moving on. Now see this question. 45.4 liters of dinitrogen reacted with dioxygen and 45.4 liters of nitrous oxide was formed, right? The reaction is given below. They have given you the reaction also. Life is made easy. All of them are gases, right? So we can apply Gay-Lussac's law of definite volumes ratio. Let us see if this follows. So 22.7 just take the ratio, right? This will be 1:1. So this exactly cuts it as 1/2. So it will be 1/2:1:1. If you do that, it becomes 1:2:2. Right? Right? So yes, it follows Gay-Lussac's law of gaseous volumes. Right? Right? Okay. Which of the following reactions is not correct according to the law of conservation of mass? Okay, let me give you this question as a homework, right? Now questions are pretty easy. Even this question, which of the following pair illustrates law of multiple proportions? I think this is a very easy cakewalk question for you, right? And at the end of this session, I would like to thank you for your patience, for listening to me throughout this time. And if you want to learn some more interesting concepts and clarify all your doubts, well, join us at Knowledge Hub by Sri Chaitanya by scanning this QR code. And bye for now.